In this video, we'll discuss about problem number 6 of uniform continuity chapter of Bartle Sherbert. In this problem, it is given that if f and g are two uniformly continuous functions on a subset A of R, and if both are bounded on A, this point is important. If any boundedness is dropped, then this result will not hold. So both the functions are bounded on A, then we have to show that their product function is also uniformly continuous on A. Okay, fine. So how we can go? Function f and g both are bounded on subset A of R, that is given. So we can take the maximum bound M for both mod f and g. That means there exists a M positive for which fx mod fx less than m and as well as mod gx less than m for all x in the set A. Now, as m is a positive number, what if m is 0? For example, if the constant function cx is 0 for all x, then it is bounded by 0. But if m is 0, then both fg are identically 0, right? In that case, their product function is also identically 0. As it is a constant function and it is identically 0, then this is also uniformly continuous. So this is very obvious. So we are assuming that m is strictly greater than 0. Why we are assuming this? Because so that we can divide it by m, right? So let us choose epsilon positive. We know that fg both are uniformly continuous. So there exists some delta 1 and delta 2 for which whenever x minus y less than delta 1, mod fx minus fy less than epsilon by 2m. We are dividing it by 2m because some calculation in the next step. Similarly, whenever x minus y less than delta, gx minus gy less than epsilon by 2m. So for these steps, we are using the result that f and g both are uniformly continuous, right? Now we have delta 1, delta 2. So we will take the minimum of delta 1, delta 2 as delta. Then for all xy in R, whenever x minus y less than delta, we are trying to compute their product difference, that is fx gx minus fy gy. And the tricky part is that we are adding and subtracting this part fy gx. Here we are subtracting fy gx and here we are adding fy gx. Now applying triangle inequality. Now for these first two parts, gx is taken outside, and for the second two parts, fy is taken outside. Now as mod gx is less than m because fg both are bounded, so we can write again by in the next step m into fx minus fy, and for this fy is also bounded, so we will take m gx minus gy. Now applying this result, whenever x minus y less than delta 1, because delta is minimum of delta 1, delta 2, so whenever x minus y less than delta, x minus y less than delta 1, so we can apply this result. So fx minus fy less than epsilon by 2m. Similarly, we can apply this result because delta is minimum of delta 1, delta 2. So this is m into epsilon by 2m. So ultimately this is less than epsilon. So what we have proven that whenever x minus y less than delta, their product difference is less than epsilon. In other words, we have proven that fx gx is uniformly continuous, right?